Ladies and gentlemen, today, in this video, we are going to look at the naming of organic compounds. When naming organic compounds, there are a set of rules that we need to follow. The first rule is that, or the first rule of naming organic compound is locate the longest carbon change in our compound. So let's look at this compound. How are we going to locate the longest carbon chain? So now, we are now going to count. If we now start counting from here, 1, 2, 3, 4, 5. So it means that if we follow this direction, 1, 2, 3, 4, 5, it means that we have 5 carbon. Because here, it's 2 carbon. So it's something like this, C. Then we have CH3. So we have CH and then CH3. So if you follow this direction, we have 1, 2, 3, 4, 5. So in this direction, we have 5. So now let's follow here. 1, 2, 3, 4, 5, 6. So in this direction, we have 6. So it means that looking at this position, we can clearly see that at this position or at this direction, we have the longest carbon chain. Why is it that we have the longest carbon chain? Is because in this direction we have 5 up, and of course in this direction we have 6. So it means that the longest number of carbon is followed in this direction. So since it follows in this direction, so we are now going to consider this direction to be our longest carbon chain. We have 6 carbon there. So now, after we count, then the next thing we name the longest carbon chain. So the longest carbon chain, based on the counting, we have 6. We have 6. So we have a root word. So we are not going to name it completely. We are to actually start with the root word. Remember the root word, since it's 6, it means it's going to be hex, not hexane, not hexene, not because the name of the compound or the final name of the compound will depend on the functional group that is present. So here we have hex. So we have hex. Since the longest carbon change is 6. So we have our longest carbon change as 6. So then what next? Then figure out what the ending should be. So we have to figure out what should be the ending of the root name. So since by looking at the compound, we can see that clearly all the carbon are bearing single bond. All the carbon are bearing single bond. So that means the compound is alkane. So therefore here the hex will now change to hexane. So we have the suffix name as N because all the carbon have single bond. So that is why it's now going to be hexane. So we now have hexane. So after that, then the next one, what do you do? Then we number your carbon atoms in the compound. So we are going to number the carbon atoms. So in numbering the carbon atoms, there are also a set of rules. So what do we do? Let's start numbering from here. We have 1, 2, 3, 4, 5, and this is 6. So after we number it, then the next thing is name the side groups, that is the substituents. Are there any side groups here? Yes, the answer is yes. We have side groups. And what are our side groups? We have bromine here, then we have ethyl here. We have bromine and of course ethyl. So now how are we going to name them? Then we name them based on their position. Like for example, 1, 2, 3. So at position 3 is where we have ethyl. Because here we have C2, H5. So this one is ethyl. This one is ethyl, and this one is bromine. So the generally halogens, they are in organic compound. When you are naming organic compound, halogens usually change to bromo, chloro, iodo. So therefore here we have bromine, so it's going to be bromo. So we have bromine. But it is important, it is also very, very important to know the position of each of the side groups, to know the position of each of the substituents. Like for example, we have ethyl at carbon 3 and we have bromo at carbon 4. So now, between bromo and ethyl, which one will come first? So that is where we have to think about the alphabetical order in naming substituent. So between ethyl and bromo, which one will come first? So bromo will come first, then followed by ethyl, because B first, then E. So therefore, the bromine here is at carbon 4. So we are now going to say 4 bromo. So between naming organic compound, between a letter and a number, there is a hyphen. And then so we have 4 bromo, and then the next one is ethyl, and ethyl is at carbon 3. So we have 3 ethyl, we have 4 bromo, 3 ethyl hexane. So that is the name of this compound. That is the name of this compound. 4 bromo, 3 ethyl hexane. That is when we number it in this direction. But when actually naming organic compound at the same time, it is also important to count from both sides so that to see which of the direction you have the lowest number, which of the direction you have, or you do have the lowest number. So now, let's see, if we come from here, what are we going to have? So let's say this is 1, and this is 2, this is 3, this is 4, this is 5, and this is 6. So based on counting in this direction, so we see here bromo, this bromo is at carbon 3. So I'm now going to say 3 bromo. We have 3 bromo. Then of course ethyl is at carbon 4. So we have 4 ethyl hexane. So now let's see. So if we now take this 4 plus 3 is going to give us 7. And of course, if we now take this 3 plus 4, it's going to give us 7. So it means that they have the same number. So generally, when there is a situation where you name a compound and you number them on both sides, and it gives you 2 different numbers. So the one with the lowest number is the one that is correct. So it's the one that you are going to pick. And if you take the one that have the highest number, it means that you are wrong. So it is very, very important when naming organic compound first, between the data and the number there is a hyphen, and between number and number there is a comma. And when you have a substituent, the best way is to arrange them in alphabetical order, like we did here. So ladies and gentlemen, let's look at another example. So here we have another compound. So how are we going to learn this compound? So the first thing is to identify the parent name. So let's count from here. When we count 1, 2, 3, 4, 5, 6, so we have 6 in this direction. Now what over here? 1, 2, 3, 4, 5, 6, 7. So we have 7. So based on this, it means that the longest carbon chain here will be considered as this, because the one with the highest number of carbon will be considered. So if you follow here, it means that this one have the longest carbon chain. So therefore, and of course, the number of carbon is 7. So we are going to say hep, because hep 10 is 7. So we are going to use the suffix, which is hep. Sorry, the prefix hep. So, but now, what will be the end of the name? What will be the end of the name? By looking at the compound based on the functional group, they all have single, double bond. So it means that the will be hep 10. So we have to number the carbon. So we have to start numbering the carbon. So we have 1 here, 2, 3, 4, 5, 6, 7. So it means that this one will be considered as a side group. This one is also a side group. This one is also a side group. This one is also a side group. So now, what we are going to consider here is the first one here, we have bromine, then we have iodine, we have methyl, and there is also ethyl. So it means that we have like 4 different substituents. We have 4 different substituents. So now, which one are we starting with? Of course, this is step 10. So which one are we starting with? So this is bromine. So the bromine is at carbon 2, so we are starting with the bromine. So now we're going to see 2 bromo. Then between iodine and methyl and ethyl, which one will come first? So after bromo is ethyl. So the ethyl is at carbon first. So we have 4 ethyl, we have 4 ethyl, and then we have iodine and methyl. So iodine will come first. So iodine is at carbon 3, so we are going to have 3 iodine, and then we have methyl, still also at carbon 3, so we have 3 methyl. So therefore, the name of the compound is going to be 2 bromo, 4 ethyl, 3 iodo, 3 methyl, hep 10. So that is that. So, and that is the name of the compound. And of course, we can also follow the same methods and see how we are going to name some of the compound. So, like for example, we can see if we now count in the other direction, like if we are counting, like for example, this one we started from this direction. So what if we started counting from here? Let's see what we are going to get. So we have 1, 2, 3, 4, 5, 6, and 7. So if we follow it in this direction, so of course our bromo is at carbon 6. So we are going to have 6 bromo, and then of course after bromo is ethyl. So ethyl is at carbon 4. So we have 4 ethyl. And then after ethyl, then is iodo. So iodo is at carbon 5. So we have 5 iodo. And of course, the methyl is also at carbon 4. So we have 5 methyl. And then the parent name is heptane. So let's see which one are we going to consider here. So first we have to add the number. So 2 plus 6, 2 plus 4 we have 6. And 6 plus 3, we have 9. And then 9 plus 3, we have 12. So we have 12 here. And then here we have 6 plus 4, we have 10. Plus 5, 15. Plus another 5, we have 20. So between this one is 20 and this one is 12. So which one have the lowest number? The one with 12. So this one is correct and this one is wrong. So this is how to name organic compound. This is how to name organic compound. So now let's look at another example. So now let's also name this compound. So in this case, we have this compound. So how are we going to name this? So the first thing that we are going to do is so we have carbon here. We have 1, we have 2, we have 3, we have 4, 5, 6, 7. And of course, if you follow 1, 2, 3, 4, 5, 6, 7. Here we also have 7. And here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we all have 7, 7. So we can decide to use this or to use this. So anyone we take, but advisably, we can just work with this. So therefore now what we are going to do is build on this numbering, we have 7 carbons. So it means that we have heptane, since they all have single bond. And of course we have iodine, and we have bromine, and we have ethyl. So we are going to start with bromine. Yeah, so 1, 2, 3, 4. So we have 4. We are going to have 4 bromo. 4 bromo. And then we have ethyl. So we have 5 ethyl. 5 ethyl. Of course, this is ethyl. 1, 2. Yeah, that is why it is ethyl. So we have 4 bromo, 5 ethyl, and then we have 6 iodo, 6 iodo, heptane. Or you can decide to start the numbering from here. Let's say 1, 2, 3, 4, 5, 6, 7. So if you follow this numbering, then the bromo is at carbon 4. We have 4 bromo. And then we have at carbon 2, sorry, at carbon 3, we have 3 ethyl. We have 3 ethyl. And then we have